Hello everyone, this is Shanko, and in this video I'm going to talk about the bridge design pattern. So the bridge design pattern is a structural design pattern, and structural design patterns decide how the entities are going to talk to each other, or how the entities would relate to each other in order to form the larger system. So to understand bridge pattern, let's take an example. Let's suppose that we have various services or various APIs. So we have this employee service, and we have a student service, and there's a service interface, or there's a service abstract class, and these services are present on load balancing server. So let's imagine we have 3 load balancing servers, and each of these services are present on all the 3 load balancing servers. So we have this service abstract class, and it has a load balancer. At runtime, it is decided which load balancing server should serve or should run this service. And then there's an abstract method inside this abstract class called run on server. So let's take a look at each of the services. So employee service, extend service, and inside run on server we have LB, that is a load balancer that is decided at runtime which instance of the load balancer should execute this service. So inside this run on server method we have lb.execute service, employee service. So let me just write here which instance of load balancing server should run the service is decided at runtime, right? And similarly we have a student service, right? And inside this again it takes the load balancer instance and then calls the execute service method. Now let's take a look at the load balancer. Load balancer is an interface, and it has got an abstract method called execute service, and it takes the service name as an input parameter. And then we have 3 implementations for load balancer. So LB1 implements load balancer, and inside execute service we have this printed. So basically this is going to run the service. So I'm printing running the service name on load balancer 1, and similarly for load balancer 2 we have running service on load balancer 2, and similarly for load balancer 3 we have running service on load balancer 3. Now let's test this. Let's say the client wants a student service, so it gets a student service here, and then which load balancing server should be used is decided at runtime. So it says that service.lb equals to new load balancer 1. So we could have any load balancer here. We could have had lb1, we could have had lb2 or lb3, any one of the load balancer server instances, and then service.run on server. So let's run this. So we have running student service on lb1. If we change this to lb2, let's see what happens. So we have running student service on lb2. Now let's say client wants to run the employee service. So let's say employee service. So running employee service on lb2. So imagine if we want to add a new load balancing server, all we need to do is we just create a new class. Let's name it lb4, and let's add load balancer as this as the interface to this, and then all we need to do is we say running plus service plus on LB4. So for adding a new server for adding a new load balancer, we don't need to make any change in the services. The services remain as they are, and the load balancer can vary on its own without changing the services. So if we run this, say we run this on load balancer 4, so let's see what happens. The newly added load balancer, so it runs perfectly. And then what if we want to add a new service? Say we add a class called product service. Sorry, SERVICE, and here we add service as a super class, and here we say lb dot execute service, and then we pass the name of the service, so say product service. So if we want to add a new service, we don't need to make any change in the load balancing servers. The load balancers remain unchanged. If you want to add a service, the load balancers remain unchanged. And if we run this, say we want to run product service, so we can run this, and this one's perfectly fine. So these two components, service and load balancer, these two components can vary independently. They are not tightly coupled, they are rather loosely coupled, and they can change independently. So if there's change in one, maybe if there's a change in a load balancer, there's no need to change the service, and if there's a change in service, there's no need to change the load balancers. So this is how the bridge pattern works. So here we have two components which can independently vary without affecting the other one. So that is how bridge pattern works, and that is the problem that bridge pattern solves. So I hope you guys enjoyed this video, and if you did enjoy, please give it a thumbs up. Thanks for watching.